Is it how we start? Hi, this is Dan here. I'm joined by Seb. We are from AWS user group Aotearoa, Wellington chapter. So we would like to welcome you all and thank you for joining online. And thanks for joining online and watching this live, and also people who would be watching this later. Recorded. We'll try to share our link. I'm here joined by Seb, who is our founder and also our vice president of our AWS user group. Hi, Seb. How are you?
Hey, I'm doing really well. Thanks for having me.
Yeah. So, Seb, thanks for joining. Just a few things we would like to hear from you is for AWS user group. I know you founded this few years back. I've been a part of this for the last 2 years, trying to run up the meetups. Some great journey for you. Just want to know what the background is for joining, for making sure that the user group is set up in the right way. And yeah.
Yeah, cool. Well, it all started in 2015, and we had our first meetup at the Green Man pub. And I'm just wondering if some people might even still remember, but it does go back quite a while. I remember it was actually February 24. I just looked it up, 2015. So nearly 7 years ago, and it was just the beginning of my own AWS journey. So I figured I need to go and build a community around those that are like-minded, and there wasn't a meetup in Wellington yet. And I had also just set up a consultancy around AWS with my business partner, Wang. So we figured, this was an opportune time to go and set up the AWS user group. And it was actually the first one in New Zealand that was set up. So after that, then came Auckland shortly after, and there were sort of a few Auckland user groups bouncing around for a while. It was a really fascinating time. We always met in person, so we didn't have any of these kind of virtual meetups that we're doing now, which is really cool to see, because of course when we go virtual, we can go global, and we're no longer restricted to just being in one city. But for a long time, it was just Wellington. We saw the numbers of members on meetup.com go up really quite astronomical. So it was very much sort of like a hockey curve, exponential kind of growth thing. But mostly, even though the numbers went up really heavily on meetup.com, a lot of them were kind of curious watchers, and we only had maybe like 50 to 70 people actually show up from Wellington. And that's been really consistent throughout the whole, sort of 7 years of running these meetups. The meetup organizations actually changed quite a lot. So over the 7 years, and I've been part of that journey the whole time, we tried various different things. We tried lunchtime meetups, we tried evening meetups, and we had, sort of breakfast meetups, and we tried all sorts of different things. And we found that you get different kind of individuals that can make it. You get people with families that can't make the evenings, but they're really keen on the lunch times, and vice versa. So we try to mix it up a bit. And that's what we're trying to do now as well, where we have some virtual events for people that might not be able to show up in person, or if we've got lockdown situation or what have you. But also obviously we're still keen on local meetups. And then recently we joined up with Christchurch really well, and we've had Logan Anderson join our nice little committee from the Christchurch user group, and it's really good to see. I guess us sort of being able to use the resources and lessons learned that what we've had. Some of the highlights, I think we won last year. We won an award at the Global User Group Summit, which was really awesome.
Yeah.
And we had Chris Watson and Gladson Nascimento both presented on how to run a user group, and they actually won a medal, which was really cool. And so we're quite proud of that. And then maybe just sort of to wrap up, we actually reconfigured our user group organizational structure really heavily about 1.5 years ago, or maybe a little bit less, just over a year ago at least. So we founded with 14 members, all based in Wellington. At the time we founded a society, a non-profit society, to go and run the user group going forward, so that there would be no vendor advantage to any one single organization, and it will be truly inclusive of absolutely everyone, and no one would be here representing the organization, representing the community. And our goal is essentially to build the next generation of AWS professionals, is what we always say. So it's about becoming the best possible professional that you can be within AWS and learning more and more about it, and therefore having a career boost as a result of it. And we've seen a lot of it, and certainly it's an incredibly rewarding journey.
Yeah, awesome. Yeah. Oh, that's definitely an amazing journey that we've had, undoubtedly. So one thing is the users would be keen to know how they can get in touch with us. What's the best way to get in touch with the user group? Maybe joining the user group as a committee member, or just becoming a member and being a part of the meetups.
Yeah, okay, and that's a really good question. So we actually run a Slack channel, and we do encourage everyone to come onto that Slack channel. That's the best way to get hold of any one of us, or really anyone in the New Zealand committee. Or in the New Zealand community for that matter. It's probably not a hugely active channel, but there are a lot of people on it. So when people do ask questions, you do get pretty high-end consulting experts being able to give you advice for free, which is always quite nice. So the best way is to join the Slack channel. Now, the link on the Slack channel is actually on our website, which is awsug.nz. We had a website there that we're just actually about to revamp. Yeah, that's the one. So you get a link there to Slack, join that, and then you can chat. We're actually always looking for anyone who wants to contribute to building the community in New Zealand. That's not just a Wellington thing. We'd be really keen to connect up more with the Hamilton user group and the Auckland user group. Any other user groups that may not exist yet. If someone wants encouragement, our goal is to be able to share the speakers and help show how we can run these kind of virtual meetups as well. So very, very keen to help. It's like I said, it's quite a rewarding and fulfilling experience being part of the community.
Sure. So I'll try to post the link on our comment section in the YouTube and LinkedIn. I'm sure it's easy search on Google, but we'll definitely do that if you're keen to join us.
Yeah, cool. Look, going forward, Danny, just before we wrap up, I just wanted to say what we're trying to do is run a combination of in-person meetups and virtual meetups. And the goal of these virtual meetups is to really showcase New Zealand content. And so even though we can have a global reach, the goal here really, it's all about Aotearoa and the New Zealand AWS community. So we're looking forward to doing more of this, and we're really thankful to have Asa on our sort of first official, well-organized virtual meetup. So yeah, Danny, thank you.
Thanks a lot, Seb. Amazing. Thanks again for joining us, and we will have a catch up later. Thanks a lot.
My pleasure.
Cool. Thank you. So for our next session, we'll have a few of our amazing speakers right from the heart of Wellington, and they're all a part of Arcanum team. And I would want to introduce them. And I did a bit of research on who they are and what they do, and I've been in touch with Asa and Ben. They're all amazing people, and I'm going to put them on. Just before I put them on, a couple of things to note is if you've got any questions to ask, please do so. And the way you could do that is just add your question in the comment section underneath the YouTube link, or if you've got anything specific to Asa, Ben, and Scott and their team, please do get them through their LinkedIn handle, and please do follow them and ask the questions directly. And once our presentation is done, what I'll do is I'll try to consolidate all the questions and lay it down in front of our speakers. I'm going to bring in our speakers. Here we go.
We are in. Thank you, Danny. So shall we just kick straight into it, Danny? Okay, let's go. All right, let me share my screen so then you can see what we are up to. Okay, thanks Seb. Thanks, Danny, for giving us the time here to bring us onto the stage. It's a shame we can't be meeting in person, but great for you to set it up in this way so we can still do a bit of bit of sharing. So I'm Asa, founder and CEO of Arcanum. Hopefully you've got the same order. I can see Scott above me, who's our CTO, and Ben down there is our head of engineering. Now, we'll each go into our own kind of stories on how we got involved in Arcanum and AI, ML, and AWS. So I won't do a bigger intro now. I'll let them tell their own stories. We're going to give you a bit of a business background in terms of how we got to what we've built. We'll kind of go through some of the problems that we see that our platform is trying to solve, and then Ben will go into the technical details. Hopefully, share some of the insights that he's building things for, and then we'll finish up with Q&A. Based on what the activity that Danny said on YouTube and LinkedIn. So feel free to post stuff in there. Okay, let's crack into it. So myself, I'm a non-technical founder. I set up the company 5.5 years ago now. It was established as Intella AI back then. We got to work pretty early on with some really awesome projects. We did work with New Zealand Police and MPI pretty early on. Our big kind of breakout with AWS was with Transpower, when we built an ML solution for processing images for power line damage detection, and then really began to build some pace in 2019 when we worked on an awesome project with New Zealand Rugby in the preparation and during the World Cup in Japan. So incredibly intense time for the team, actually trying to turn around a whole bunch of stuff in between games, which was super exciting. And we actually span that tech out into another business unit called Play in the Grey, which is a joint venture with another Wellington company called Dotloves Data, who many of you might know. And actually now Play in the Grey is working on American football, NRL, and soon soccer as well. And watch this space for some announcements on that in the next few weeks. But we've worked across a whole bunch of different machine learning and across a whole bunch of different sectors. So it's been super exciting to be able to build out the team and the company to work with other awesome New Zealand entities, including now UBCO, which is going great guns, Atlantis Healthcare up in Auckland, Farm Focus over in the Wairarapa, Verifies up in Auckland too. And we're kind of bringing on more and more organizations now who want to add new machine learning features into their existing software, or they want to add machine learning capability more broadly, either within their BI departments or elsewhere. But I come from, say, business background. So I'm the non-technical one. I'm the translator of people's intelligence within our team, and I try and turn it into what the business community actually needs. So that's my background, but I'll hand over to Scott, who's got a much more interesting story.
Thanks, Asa. I'm Scott Houston. I was the founder of a company called Green Button back in 2005, which we sold to Microsoft. So in 2014. So the photo in the bottom is the before, and the photo at the top was the after. So I've warned Asa about this whole entrepreneurial thing. It is hard, but seriously, no, I don't. Hopefully, I don't look like Gollum. Actually, the background to Green Button was we had a whole lot of rendering capacity left over at Weta Digital. I was the CTO of Weta Digital, and at the conclusion of the movies, and we did some work on Van Helsing and iRobot in 2004. But our next big project was going to be King Kong. So Peter and Richard were just going to turn off the servers for a couple of years until we needed them again for King Kong. And I saw a business opportunity and founded the New Zealand Supercomputer Centre in 2005. And at the time, it was the second largest on-demand computing facility in the world, using all of the rendering capacity of Lord of the Rings. But I realized there was an opportunity to create some software to automate that process. So it was, even before cloud computing, was a sort of orchestration tool. And the idea was you sat in you work in your application, you push the button, and the job was offloaded, sent to Weta and then to the cloud, processed and sent back to you. We work with AWS and Microsoft, but in 2014, Microsoft acquired the company, and like all entrepreneurs, I retired and said, that's it. I took up golf and fishing. Turns out I'm not very good at golf and fishing, and I joined a company called Sequent in Christchurch. I was the CTO of Sequent, and they were just recently bought by Bentley Systems for $1.5 billion. And I decided my career as a CTO was over, and I would write a book about AI. I've got a fictional novel about a sentient algorithm, an algorithm that becomes sentient, which I'm happy to share with you on LinkedIn. Hopefully finish it this year. It's taken 3 years, but I realized I didn't know enough about AI, and so I looked around for companies that were doing great things in AI, and that's where I came across ASA and the team at Intella that became Arcanum. So really enjoying being part of the team. Some of the technology that we're creating and some of the solutions that we're providing are world class, and so who knows, they could be the next Sequent or Green Button. And I'll hand over to Ben.
Thanks to God. Isaac, can you please go to the next slide? Cool. My name is Ben, head of engineering in Arcanum. I've been in software development industry for 13 years, 6 years in China and 7 years in New Zealand. There were a couple of highlights in my career in China. I worked for a company with 100 million users. I also joined a startup, recruited the team, and at the end of the journey, I led a team of 20 developers. After moving to New Zealand, I worked for TradeMe for 4.5 years, but I didn't work on TradeMe website. I mainly work on AA SmartView, which is a loyalty program for petrol stations. I guess a lot of New Zealanders have been using AA SmartView for quite a while. I built a big data platform for AA SmartView. They are still using it without any issues, apart from a couple of incidents caused by human errors. After that, I joined Mobitgo as a senior platform engineer. But I was always very keen to apply machine learning algorithms to Mobitgo products. So I was transitioned from a senior platform engineer to machine learning engineering lead. In my experience in Mobitgo, I did a bunch of manual deployment for machine learning models. It was not ideal at all. I was always thinking of creating an automatic process to deploy machine learning models. And then ASA talked to me and saying that they were planning to build a machine learning ops platform to automatically deploy machine learning models. That was exactly the thing I want to do. So I joined ASA to build a platform. Apart from my work experience, I've also been doing a PhD research study in Victoria University. My research topic is more about deep learning. I worked on AutoML for designing convolutional neural networks for image classification tasks. But recently I started to dive into another very interesting research topic, which is explainable deep learning, which is to explain why the deep convolutional neural networks are making specific predictions. I got a short paper published and also working on another journal paper in that area. Back to you, Asa.
Thank you, Ben. As I said, both of them have much more interesting stories than I do in terms of technology. Great to have them both involved in Arcanum and building out Arcanum as a New Zealand-centered company. I just want to spend a little bit of time, and the three of us will pitch in again on kind of where we see things going, the kind of vision for the tech that we're working on. I've spent a bit of time kind of studying and talking about exponential technologies and the fact that AI ML will at some point just become software like everything else. And it shouldn't be treated as a bolt-on technology. It really should be considered as fundamental and foundational. Kind of see AI ML momentum building over the years since I started the business. The conversations have moved from what's possible to how do we do it. It's taken probably 4.5 years for that to happen, but kind of see that as a big progress moving forwards. And really, we want what we're doing, and specifically our Accelerate platform, to help with that momentum, to be able to remove the barriers to progress. The little gift there with the aeroplanes is to remind me to talk about the kind of concept. When we've been working in the past building proof of concepts and building products, it's kind of like we've been building jet planes. And the enterprise customers that we've been talking to have mainly been focused on building airports, trying to figure out the data warehousing, the data pipeline, some of the DevOps type stuff. But nobody really built a runway. And so that's where we've kind of got to now, is in order for us to help land more planes and build momentum with ML, we've now kind of built this runway for others to connect to land their own planes on, and also to land some of the stuff that we've been building as well. So that's where I kind of see things going. Again, more than happy to talk to anybody about this. It's obviously one of the things that I need to and am most passionate about. Scott, hand over to you.
Yeah, look, I find it really uncanny how the evolution of AI parallels the evolution of cloud computing. Back when we founded the New Zealand Computer Centre, cloud computing they didn't even have the term cloud computing. But the key point of differentiation I see was the global financial crisis of 2007 and 2008. And that was really when the financial strains on businesses kind of forced or accelerated cloud adoption. And so I see the global financial crisis as the forerunner of three key things. One was the online platforms like Airbnb and Uber, all created around that time. Rise of retail shopping, but cloud computing is probably the most significant. And post the global financial crisis, we saw this fantastic uptake in cloud computing. It wasn't as hard to sell. Questions of security and firewall and ease of use and cost just became easier. And today, cloud, as you all know, because you're part of the environment, cloud is just ubiquitous across all enterprises and businesses. What we see happening with the GFC is the rush to automation is as a result of the of the COVID crisis. So what we're seeing with many organizations, both in New Zealand and across the world, is they're rebuilding the heart of their business and the core of their business and integrating AI, machine learning, and automation. And what we will see is just a massive acceleration in AI. And so the key components around the use of AI, and our real philosophy is around the democratization of AI. We don't want to engage with customers and do a $500,000 project and look for a year implementation. Our goal is to either help build a model or take a model that is pre-built and deploy that into production in hours, if not minutes in the future. So things like building a pathway to take the model from the Jupyter notebook and all the way into production. And then when that model's into production, is to optimize that model on an ongoing basis is really at the heart of the things that we're doing. So, and one of the key things that we're looking to do is actually use AI to actually build the AI and optimize the AI going forward with tools like meta learning. So we'll talk a little bit more about that afterwards. I think I'm handing over to Ben next.
Cool, thanks, Scott. I think, as I mentioned before, I did a bunch of manual process of deploying machine learning models. I do find it's difficult to deploy the machine learning models by manual process. There are kind of two flaws, in my opinion. The first flaw is that the process is slow. We'll have to develop the whole process for every machine learning model separately, and then deploy the machine learning models. That's why we want to develop an automation process to deploy machine learning models. Whenever we get a machine learning model, we run our automatic process. It could be deployed to the production environment in hours. And another flaw for manually deploying machine learning model is that it needs knowledge, it needs human knowledge. Like for data scientists can build the prototype. And when the data scientists hand over the prototype to the DevOps, in the current circumstances, most of DevOps know how to deploy a website, but not a lot of DevOps know how to deploy a machine learning model. So it's kind of, we need to bridge the gap to make the productionization process much easier for DevOps and also for the data scientists. We want to build a platform, and which is underway, and we want to make sure there is no learning curve for both the data scientists and the DevOps. So the work for the data scientists and the DevOps are the same as what they are doing now, but we are just bridging the gap. So we don't bring any burden to data scientists and DevOps person. And another thing we noticed is that for machine learning models, when people deploy it, they just use the kind of standard monitoring system for websites to monitor machine learning models. That's kind of do the work, but it doesn't really monitor the machine learning models. What we are trying to propose is that we are going to monitor the actual performance of the model. We are going to monitor the input, output of the model to make sure the model is performing as we expected. And that's what our platform is going to focus on. Back to you, Asa.
Thanks, Ben. And Ben will go into a lot more detail on those various components in a few minutes' time. What I wanted to do was just to kind of give some ideation and give some context to what we're working on. We really want to enable organizations, and I'm sure many of you watching this are in and work for those organizations that want to add new features, new intelligent features to existing software stacks, to existing mobile apps, to existing business intelligence dashboards, and so on. And we really see that as that drive to iApps, those that are adaptive, that understand context, that putting recommendations and predictions, that's where us as users, that's what we're demanding, that's what we're looking for. But we kind of think there's like 3 tiers of this AI ML integration or feature sets, and 3 different kind of categories in that. And the first one is quite obvious. It's the ML native kind of organizations, the ones that we now know and love because they are personalized. They do respond to our activity, and they just do things better, right? And they were built from the ground up using AI ML. And we know that now that this is all possible. Thinking about another tier where there's integration. So whether it be with Amazon, with recommendation engines, with Tinder, with the same thing, Power BI, with again intelligent predictions being embedded, Zero predicting codes for invoices or for expenses, Elsa, which is a teaching English kind of platform. So again, you can see they're not native, as in everything isn't based on it, but they have very, very strong ML integration. And then the kind of third category, as we look at it, is where there's kind of more specific features. So looking at some things like the Face Me app, Halter with some of its intelligent cattle movement, Portio with email assessment, Ambit, the chat company with their kind of chat systems. So kind of looking at the fact that they've added a feature which is differentiated, which does kind of make them unique, or is quite a strong value proposition. So kind of look at those different tiers in terms of how we see those intelligent applications. Now, when we think about some of the specifics of those, so looking at what types of intelligent features there are, we can think about prediction features. So Uber predicting how long it will take for a car to arrive and then how long it would take to get there. A recommendation engine, of course, Spotify and Netflix kind of jump out. Then looking at extraction of information. So say, for example, expense processing. We work with Henry in Wellington to process some of the information that comes from paper-based receipts, and then conversion of code, conversion of languages. So we all kind of have experiences with some of these but there's a lot of other ways in which we can add some of these intelligent features into the existing enterprise software to be more like Netflix and a little less like Sky, to put it quite broadly. Oh, I've gone the wrong way somehow. Let's try this again. Oh, I'm going backwards. Why am I suddenly going backwards? That's a bit weird. Let me try and... Wow, it's all going backwards. Sorry about this. I'll keep going. Okay. What we wanted to do is a quick live poll. So hopefully you can now go to that URL or use the QR code there. I think I do need to activate this. So let me activate it and present it. So what we wanted to do in the context of intelligent applications and intelligent organizations, at what stage is your company? So this is a live poll, hopefully, where you can now use the QR code, go to the URL, and actually put your answer in. So what stage is your organization? Looking at kind of that maturity curve. Is it already fully integrated, more like kind of a native organization? Is it all pervasive and disruptive, and there's kind of change underway? Is it that there is some AI/ML in production, or just that some POCs have been done? Or is it that your organization is just thinking about it right now? Or is it none of the above? Thank you, Danny, for posting that. So we see a whole wide range. If we look across New Zealand, then there's probably a skew towards the bottom end of that. So from the thinking to the proof of concepts, globally, it's probably not too dissimilar, but you can imagine the more mature markets that there's a bit more integration, a bit more spend, a bit more commitment, and so on and so forth. So it'd be interesting, and we can keep this open for a little while to see what kind of stage organizations that are on here, how they describe where they're at. So we'll show that again a little later on once we've got a few more results, and there will be another poll later on as well. Okay, let me switch back to the presentation. But good to see that the tech actually works. That was at least the first test, a live test of a live poll. So that was good. So, of course, when we start to look at the problems that organizations are experiencing in adding intelligence to applications, there's a number of different things. The first thing, of course, is none of us are Spotify or Netflix or anybody that's an ML native company. So we shouldn't expect to go from where we're at to straight to one of those world dominating multi-billion-dollar budget kind of companies. So that's just one thing we want to be clear of. If organizations are trying to get to that, that's a long journey. However, on the other side, we also find that there's quite depressed expectations. In New Zealand specifically, the pace at which things are done is relatively slow, and some of that is the ecosystem that's around us, the old school kind of IT modality, the vendor landscape, and so on, where things just seem to take a heck of a lot longer than in some other countries and in certain size organizations. One thing which is common globally is the fact that teams are still highly disconnected. That the data team, the data science team even, the software team, the DevOps teams are all pretty siloed and not particularly connected. And as a result, I guess, of some of that siloed working and the expectation suppression means that the skills haven't been developed ahead of time. So as kind of been described and will describe in a bit more detail, the kind of skills that are needed to productionize ML, to add intelligent features into software, a lot of those skills are missing in New Zealand, but also many other markets as well. And I'm sure all of us have been involved in projects or organizations where the commitment is more to data warehousing and mobile apps than it is into the bit in the middle. So the transformation efforts and focus also aren't in this area. They're either kind of BI kind of projects, or maybe they are mobile app refreshes and a bit focused on UX. But there isn't kind of a focus on this transformational layer of AI or ML kind of technologies. And of course, that's on us as an organization, on AWS as an organization, and as the community more broadly, to really help executives and leaders begin to really kind of build on the right kind of transformations. So that's where we kind of see intelligent applications, and hopefully some of that resonates with you, and also some of the challenges that we see in the market as well. Scott, I'm going to hand over to you to talk through this slide. Oh, you mute, Scott. No, I mute first.
Sorry, guys. Yeah, sadly, over the last 5 years, we've probably built around 50 models for customers, and very few of them actually have made it into production. And there's a variety of reasons. Sometimes you just get stuck on the Jupyter notebook, or there are proof of concepts that never make it into production. Sometimes even the bravery of the organization to embed AI at the heart of their customer engagement. But for a variety of reasons, we see a lot of, and we've actually built a lot of models that really never see the light of day. And so what we wanted to do was automate that process, really kind of grease the skids to enable those models to make it into production. So at the heart of it really is the Jupyter notebook. And so we're working on ways to automate the upload of the Jupyter notebook into the environment. And so what will happen then is we can break down the Jupyter notebook into the core services, and then create a repository of libraries of those services. So it could be a repository of models, or components of models, or containers. And so in many cases, it enables organizations to reuse those models through these different repositories. The other area, and was really interesting in the early days of cloud computing, understanding the actual cost of running your job in the cloud was really kind of a little bit hairy at times. And one of the barriers to wide-scale adoption of cloud computing was, just how much is this whole thing going to cost? So part of the process that Ben will take you through is we're developing a way to kind of figure out a way, either on a per transaction cost or as a service, how much the AI model or the AI workflow will cost once it gets into production. And then we want to ease that deployment, and it could be on AWS, it could be on Azure, a variety of other cloud platforms, it could be Docker containers. And so we've actually been working with a company called OutSystems to really develop a drag and drop solution. So it's really easy to use. It's we don't expect super non-technical users to be creating and building their own models and deploying them into production, but the whole platform encompasses the data scientists, the DevOps teams, and the CI/CD teams in a really elegant way to manage models, to estimate the costs, and then to optimize those models while they're in production, and look for any performance issues, and improve the performance of the models on an ongoing basis. But as they say, a demo is worth 1,000 flowcharts. So over to you, Asa, for a live demo.
Yeah, conscious of time, but I will just kind of show a few of the user interfaces, and then give Ben the floor to better go into the details. I've just seen on the chat that if you are on the YouTube channel, you need to refresh the page in order for the chat to work. Thanks, Tom. Thanks, Chris, for flagging that up. But I will just show, if I can, in here, kind of where we've got to with our platform. Say we're working with OutSystems, which is another AWS marketplace vendor, and just kind of want to show you a few of the things. So Ben will walk you through really all of the things that we're doing when you add and create a project, and you can upload a notebook. He'll go through the details of what's actually happening there. But this is the kind of data scientist view with all the various projects. And you can see within these the things that the status is that they have, and whether they're in production or not, the kind of cost estimates and the budgets that have already been approved, and importantly the monitoring, which Ben will go into some detail around. So this is the data scientist view, and then we have a very basic at the moment kind of DevOps view, which we'd love to get people's feedback on from this group, which basically is focused on changing the status of the various workflows for whether they're on staging all the way through to prod and so on. But we're working on a huge backlog, and Ben and the team are incredibly busy working through that because we only launched the beta last week, and we've got a lot of things we want to work on, and we'd be really, really keen to get your feedback on that as we after during this presentation or after the presentation. That'll be super, super valuable. But now I think it's time to hear from a lot more from the guy that you want to hear from, which is that can talk to you about all the AWS stuff that is under the hood. Ben, the floor is yours for a while.
Thanks, Asa. As Asa mentioned previously, we got a platform, and this is what's happening under the hood. It's more about technical details. Sometimes people might find it boring, but that's the important part. And also, I'll try to keep it simple and quick to go through what we did for the platform under the hood. And let's start with a simple example. In our platform, we need a Jupyter notebook as the input of the platform. On the right side of the slide, you can see that there is a very simple Jupyter notebook. We take it as a sample Jupyter notebook. Usually, there are 4 parts of the sections in the Jupyter notebook that are very important to us. The first part is loading the data set. Second part is to initialize the model. Once the model is initialized, we need to use the training data set to train the model. Once the model is trained, we can use the model, save the model, and in the model prediction part, we'll load the model and perform the prediction. As people can see that it's in the Jupyter notebook, the data scientist will get everything, like the model build and the model prediction, also loading the data. But how to convert this simple Jupyter notebook to an API service, that's what we are doing, because you cannot call a Jupyter notebook to give you some results. Asa, can you please go to the next slide? And this is the output of our platform. We definitely need to deploy the machine learning model as a service, as an API service. So every developer can call the API service, can integrate the machine learning API service to their applications. For example, if you have an e-commerce website, you want to integrate a recommender system to the website, you just need to call the recommendation service we deployed for you. So you don't need to get some people who have expertise to deploy a machine learning model. And the next part is the API documentation, because every developer loves a good API documentation. Swagger API documentation is kind of the standard for a lot of developers. So we'll also produce the API documentation for the client's developers. The client's developer just take the API documentation and develop their application based on the machine learning model API service. Another important part for us is to get the client a CI/CD pipeline. So in the future, the client can develop deployment without any concerns. On the left bottom side, we've got a CI/CD pipeline. This is using GitLab as an example. The first stage is to build the image. The second stage is to do some tests to make sure the image was built successfully. And the next stage is to do some Terraform planning, which is to prepare the infrastructure code as service for the deployment. If the client has some DevOps resource, they can check the Terraform plan stage to make sure what we are doing is what they are expecting. In most of the cases, we are doing the best for the client, so the client should be quite happy with it. And after get the approval from the DevOps, the the client just need to click the button in the final stage to deploy the container. For this slide, it's kind of dive into more details of the technical things. It's about our code, the code generated by our platform. We're not developing a set of code for a customer. We are developing a template for the customer, and the code is generated by our template. Our template contains everything needed for API service. If you take a look at the right side, from the top to the bottom, we got the API service. We wrap up the machine learning model in the Python framework. We use a synchronous framework to guarantee the performance of the API service. And the next part is the containerization. We'll containerize the API service developed under the Python framework to a container, to a Docker container, which can be deployed in any of the cloud platform. For example, AWS ECS. And the next part is the infrastructure as code. We have a bunch of Terraform code to do kind of two things. The first thing is to deploy the whole infrastructure where the Docker container will be running. And the next part is to deploy the actual container to the infrastructure created. And the last piece of the code is the CI/CD pipeline. Again, we are using GitLab as an example, and we are underway of developing the CI/CD pipeline for others. Once the client get the pipeline, they can just check what we are doing and deploy to their production environment just by clicking a button. Asa, next slide, please. In our automated productionization journey, we haven't got the fully automation. The one step that stop us from fully automation is extract the model prediction function from the Jupyter notebook. As you can see, the left bottom side is the model prediction function extracted from the previous Jupyter notebook. It's quite straightforward to extract the model prediction functions. And we are also working towards an automated process to extract the model prediction function from the Jupyter notebook. We are underway to develop a Jupyter notebook plugin, which can be plugged in for the data scientist. And the data scientist just need to do some clicks and then produce the model prediction function, which can be uploaded to our platform. And there are a few steps, obviously, we have done to automate the process. There are 3 important steps, but not limited to the 3 steps. We've done quite a lot of other things as well. But for the 3 most important steps, which are download the model, we'll try to make it efficient to download the model for the API service. And also by loading the model, we also need to guarantee the performance of loading the model. We don't want to load model multiple times. We'll need to make sure we are using the minimum computing resource to run the model. And again, we provide API route to serve as an API service for the model. All of them will be happening automatically. So that's kind of how we speed up the deployment process. We only need one manual step now, but we'll remove that step in the future very soon.
Ben, there's just a question from Isa. Do we copy Jupyter notebooks to Pycharm?
No, we don't. We don't copy Jupyter notebook. When we get the Jupyter notebook, what we need is to extract a model prediction function. We don't check the data training or the model training part. We just take the model prediction function. And another thing we need from the client is the pre-trained model, because we don't want to touch the customer's data due to data privacy. We just take the pre-trained model by the data scientist. And if you take a look at the model prediction function, there is a parameter called model. That's the pre-trained model. Just pass the model to the model prediction function. and then we'll call the prediction method developed in the Jupyter notebook. That's the only thing we need from the Jupyter notebook.
Thanks, Ben. Steve, I will come back to your question a little bit later on, if that's okay. I'll just move on to the next slide, Ben.
Cool, thanks. As we mentioned before, like monitoring for machine learning models is definitely different from the standard monitoring for websites. What we are doing here is that we get two environments. Sorry that the yellow color might not be that obvious, but anyway, we got the customer environment, and we also get Arcanum environment. For us, it's like the reason of us separating the two environments is that we don't want to touch any of the customer's data, just to keep the customer's data in-house. One is for security reason, the other one is for data privacy reason. And what we are going to do is that we are going to develop an API container and deploy the API container to the customer's environment. And also we'll have a monitoring part deployed to the customer service, which is the drift detection container in the customer environment. If you look at the two black box, those are the two containers we'll deploy in the customer's environment. For our drift detection container, we don't collect the user's data to our platform. What we are doing here is that we'll have a Python library to accept the input and output of the model as the drift detection data, and compare the drift detection data to the reference data to produce a drift value. And based on the drift value, we create a method called Severity. The drift value means that if the model is not performing very well, the drift value will be very high. It means that the model has been drifted. And based on the drift value, we have a strategy of defining the severity. For example, you get 25% of the features that are drifted. We might define the severity as 1. And if you have 95% of the features has been drifted, the severity value will be very high. And the drift value and the severity will be passed to Arcanum environment. And I just need to emphasize the drift value and the severity are the only thing that are passed to Arcanum environment. That's because we are trying to secure the customer's data inside their own environment. And in Arcanum environment, we got a monitor API which can accept the two values, drift value and severity, and will display the two values in our dashboard. I'll show you the dashboard in the next slide. But before showing you that, sorry, Asa, can you go back just for a second? Cool, thanks. And another functionality for the monitoring that we can set up a threshold for the drift value and the severity. If the drift value and severity produced by our drift detection container has passed the threshold, we'll send a notification to the client to make sure the client will know that their model has been drifted, and they need to go on their API container, or they need to contact us to kind of figure out the issues of their model. And at the bottom part, we are underway of developing a lot of drift detection libraries. We've developed one, but we are still developing a lot of drift detection libraries for different models. For example, computer vision library, which is used to monitor the computer vision models. And natural language processing drift detection library is for monitoring some natural language processing models. That's also what I mentioned before. You cannot use the traditional standard monitoring system to monitor machine learning models. We'll need to develop different strategies to monitor different models. Asa, next slide, please. But this is the monitoring I was going to show you. From the bottom one, let's take a look at the bottom figure first. The font might be too small, but there are kind of two values, which is drift value and severity. We are showing them in one graph. So the DevOps or data scientist can see the curve of the monitoring system to make sure you don't get a big spike for the monitoring system. If you get a big spike, it means that there is something wrong with the system. And also in our UI, you can turn on and turn off the drift metric or the severity metric, which is shown in the top figure. Is the next slide, please. This is also another important feature especially for the business. The business wants to know the cost. So we did a cost estimation in our platform. Currently, we have two versions of the cost estimation. One version is the basic version because we are starting our platform from 0 to 1. So we haven't get a lot of models inside the platform. So we don't know the real cost of the models. But along with running the platform, we'll get more and more data. But for the first version, we are using a basic cost estimation, which is API-based. What we are doing for the basic cost estimation is that once we get a pre-trained model and the Jupyter notebook, we'll estimate the computing resource to run the pre-trained model and the model prediction function as an API service. After we kind of define the estimated computing resource, we'll call the cloud API. For example, if you use AWS, we'll call AWS API to get an estimated cost. The cost will be shown to the business part of the business or DevOps just to approve the cost to make sure it doesn't blow the budget. And the predicted cost will be passed to Arcanum dashboard. We'll show the person who have the access to the cost estimation. And also when the model is running on their live environment, we'll collect the real cost. But again, we'll need to get the approval from the client to make sure we are on the same page. The client allowed us to collect the data. But that's kind of, apart from the real cost, we don't collect any other data from the customer. So the customer shouldn't be too worried about this part. And once we collect the real cost, we'll form a model cost data set. We'll keep adding the record into the model cost data sets along with us hosting more and more models. Once we get a data set that's sufficient to train our machine learning models, we'll train a machine learning model assisted cost estimation. And then we'll swap the machine learning assisted cost estimation with the basic estimation. What we are expecting for the machine learning assisted cost estimation is that we want to get a better accuracy for the estimation. Because for running different models, you might need different computing resource based on the rules of the basic estimation. We might not get a very good accuracy, like let's say 95% accuracy. We might not be able to reach that level of accuracy. But with machine learning assisted cost estimation, we are targeting to get a very good accuracy for predicting the cost for the business. Cool. Next slide. Sorry, is it just going back? This is the step I mentioned previously. We are underway of developing a Jupyter notebook plugin to automate the final step. What will be included in the Jupyter notebook plugin is that first, we'll provide a functionality for the data scientist to mark some of the cells in the Jupyter notebook. For example, you can mark some of the libraries you're using as import. And you can also mark some of the cells you use to train the model as training. and some of the cells you use to perform a prediction as predict. And what we are doing here is that we are going to validate the Jupyter Notebook by the Jupyter Notebook plugin. We'll make sure the training process is successful in the Jupyter Notebook. Otherwise, we'll push back the notebook and notify the data scientist that there's something wrong with the training part of the Jupyter Notebook. And another part is the prediction part, because the data scientists are the best person to mark the prediction cells, because they have the best knowledge for their own Jupyter Notebook. After they mark all of the cells for the prediction function, we are getting a process of converting the Jupyter Notebook cells to a model prediction function, which we have shown you guys before. After the development here, in the future, we hope the data scientists could use this Jupyter Notebook plugin to make our platform automation to be fully automated. We don't want any manual step. Cool. Next. Isa, next, please. In the previous slides, I've introduced all of the functionalities. Either we have fully developed or we have partially developed in our platform. And here is a roadmap for our future plan. The future is not long away; it's very near future. And there are a list of items in the roadmap. And I think Asa is going to run a poll again to help us to prioritize what we are going to develop in the short term. I think I'll go through the items very quickly. The first one is CI/CD pipeline. As we mentioned before, we developed GitLab pipeline, but we are still expecting to have some other requirements for other platforms. For example, GitHub, Circle CI, and AWS DevOps tools, and similar things. But that's depending on the requirements to help us to prioritize this item. And also Jupyter Notebook IDE integration. What we wanted to do is that you know that in SageMaker or Azure they got ML Studio, and we want to make data science life much easier. We want to integrate those tools into our Jupyter Notebook plugins, and also monitoring tooling integration. And that's related to the monitoring I discussed before, the standard monitoring. Apart from our machine learning model monitoring, we might also want to show the standard monitoring inside our platform. But definitely the DevOps can go to AWS or GCP to check the monitoring. But we are just wondering if we offer the clients to put everything together, will the client's life be easier or not? Next one is model build platform integration. Again, we want to integrate different model build platform into our platform, if that can be easier or that provides some convenience to the data scientist. And next one is automated model code conversion. That's basically something we are working on. And if some clients talk to us and saying that that's the top one priority, and we'll definitely prioritize it as the top one for our platform development at the moment. And the last one is, as people know that there are a lot of existing machine learning services, like in AWS, they got the text extractor and some other recommendation services. We are just wondering whether the clients want to integrate those services, and how does the data scientists prefer to integrate the services? Cool. Asa, back to you.
Thank you. I'm just going to try and figure out how to keep the polls open a little bit longer, because I know it was not simple. Let me very quickly see if I can figure out the settings that Sophie's helped me with, which I can't. How do I? No, I can't see it, unfortunately. Drop down under questions. Oh dear. No, can't, unfortunately. But what I'll do is still go back and I'll do the two polls that we were looking at. And coming to this one. So as Ben was just talking about, I'll kind of keep this open for a few minutes so people can cast their votes. But what, in your opinion, should we prioritize on our roadmap of the things that Ben's just talked about? And this is, not purely for research purposes. We are, as you may or may not have seen on LinkedIn, we've got an early access program as part of our beta, and we want people to actively get involved in establishing our roadmap. So as part of that, there will be a Slack channel and pretty active conversations with Ben and the team, to be able to help us figure out what we should prioritize, how we should prioritize it, and you'll get early access to new features. You'd get grandfathered pricing, a whole bunch of other stuff as part of our early access program. There is a slide on that, but I figured I'd talk about it now while we're waiting for a couple of votes to come in. And it seems pretty top weighted over there at the moment, which is great. That makes it pretty clear. So this is interesting. This is down at the the data science end. So it'll be interesting to talk to Danny and to Seb and to Chris afterwards to see the members that were on this particular session and whether that's reflective of the votes here. I haven't got much more movement. So what I will do actually is go back to the. Oh, maybe I can set it there. No, that's just a timer. I'll go back to the other one and reactivate this one. So then for those that weren't able to vote at that point, I can now reactivate it and you can cast your votes now on this one. I don't actually know how it works on the on the web app, so hopefully it's obvious that you can switch between the two surveys and you can add some more votes on this one now. Hopefully we can see at least one change. Or maybe not. Can anybody confirm that this you can actually still get access to this one? Oh, there we go. Okay, there are some changes. Awesome. Sweet. So as I said, actually, maybe I'll just keep this open for a little while longer and invite people now to give in any questions via YouTube or via LinkedIn for any of us, but probably Ben, because he's the technical one. Don't ask Scott or I really technical questions. If you want to talk about algorithmic sentience, then direct that one towards Scott. If you want to talk any kind of business stuff, you can talk to me. But anything technical, you have to address it to Ben. I will, at this point, just answer Stephen's questions when he asked, what's the benefits of our approach over Amazon SageMaker? There's a number of them. And obviously Ben can answer the technical questions if you have any, but from a business perspective, you get a lot more control. We've been kind of looking at SageMaker from the very beginning and now looking at SageMaker Studio. It invokes a heck of a lot of resources that you don't realize, and it's very hard to shut them all down. Cost estimation is also pretty tough, and you don't get all of the flexibility with our model with the deployment configuration. If you've got some other kind of container orchestration layer, then that also is not something that's quite, isn't easy within SageMaker. And also, depending on the size of the organization you're working in, yes, there is some convenience by using SageMaker, but it's still a relatively challenging thing to go all the way through from start to finish and come up with that integration. So for us, we're kind of targeting organizations that don't have a huge team or don't have resources that can dedicate themselves to learning all the nuances of SageMaker. We've got to say that we've got 2 or 3 clients that started themselves in SageMaker, and then they've come to us, and we've kind of deployed that infrastructure in the process that Ben talked about to make it more optimized in terms of cost, to make it more repeatable in terms of that deployment process. But more than happy, Stephen, to set up a more technical discussion around that if of interest. Ben, have you got any comments on SageMaker?
I think you had a very good answer. Just one thing, we are cross-platform, so you don't have to use AWS, because if you use SageMaker, you have to use AWS. It's kind of platform specific. But what we are doing that we don't want to give a lot more learning curve for data scientists. So you just need to know Jupyter notebooks to create a prototype for data science model. And that's all for our platform. But for SageMaker, you have to basically understand how to deploy the thing through SageMaker. That's definitely a learning curve for data scientists.
Thanks, Ben.
I think also the point of difference is our monitoring capability going forward as well, Asa.
Yeah, absolutely. Yeah, I mean, SageMaker Studio does have a monitoring component, but I think at the moment when we last looked at it, it was kind of just pushing an API to CloudWatch. No capability to customize it for the model. It was pretty basic metrics. So you're absolutely right there, Scott. I would certainly be intrigued afterwards to see who cast their vote for AIML is across the whole organization. If you want to confess it on chat, go ahead. But yeah, certainly be interested to understand who that is in New Zealand, or maybe it's in Australia, maybe it's worldwide. As Seb said, we could be anywhere. Okay, well, I think that's true. Yeah, that's true. Or maybe it's one of our team. Right? Okay, Danny, I think we're done here. Thanks everyone for your time and attention. Thanks for bearing with us as we dealt with some of the technology issues on the polls. And thank you for everybody who's been firing in questions online. Really much appreciated. Thank you, Danny. Back to you. Question mark?
Awesome. Thanks a lot, Asa. That's amazing. It's amazing how you went through from who you are to where you are now. And it's always amazing to hear from companies who are from Wellington. Wish you all the best. And if there's any more questions, I will direct towards you. I know where you are on your LinkedIn. So thanks a lot. Thanks a lot, Ben and Scott. Thank you.
Thanks, Danny.
All right. Thanks a lot for joining us today. It was an amazing session from 3 of our amazing speakers. It's one of a keen example of how Wellington and companies in Wellington are trying to build stuff that can go global in minutes using AWS. And if you've got any questions, feel free to reach out to us. Just like what Seb did mention when we started, please do join us. And if you're in Wellington, and if you are not in Wellington, if you want to just connect with us online, please do join us. And last but not least, thanks to Belinda from AWS, who sent us some goodies, and she sent us some T-shirts for us to share with our committee and the community within New Zealand. So if you're interested in getting a freebie, please do reach out to us, and we can find a way to send a T-shirt towards you. Thank you, and see you again for the next meetup for next month, and keep looking out for our channel, social media channels, to get the latest updates from what we're doing from Wellington. Thanks a lot. See ya.